Hello everybody, in this video I'm going to be reviewing 5-year survivability, and I'm going to review this first question, which is calculating the 5-year survivability for this disease using the life table method. I did take out a question on using the cohort method, simply because that is not going to be on the final exam, as well as the Kaplan-Meier. That is not on the exam, neither in calculation or multiple choice questions. I just know it's a little information overload for many of you. But the cohort method, if we were to do that, it would be taking the survival at year 5 over the starting population, only with this first people who were in all 5 years of the study. So I mentioned that because that is a good introduction to one of the advantages of using the life table method is that we get to use multiple years of data, and not only people that have been followed for 5 years. We're also going to incorporate people that have been followed for 4 years, 3 years, 2 years, 1 year. So that's one of the advantages. So to calculate the overall 5-year survivability, we need to calculate the survivability of each year from each year for 5, and then multiply those. So I'm going to go over that with you, but what we are solving for first is the probability of each year. So we need P1, P2, P4, P5, and each one of these is going to be a decimal number under 1, or a percentage if you wish to convert it. So an important thing to remember is when you're calculating the first probability of year 1, it's a little bit easier. There's an additional step for the other ones. So conceptually, this is very simple. All we're doing is looking at people alive after 1 year divided by total people who began the study. And when I say begin the study, I mean begin the study at any point in time, at least for this first 1 year probability, because if they were if they enrolled in the study in 2003, they only have 1 year of data, so we can't calculate any further. But for this first one, it's going to include everybody. So what we need to do is we need to simply add up the total number of patients enrolled in the study across all years. So that will be total down here. And if you're doing this, I would just go ahead and do that for all years of the study. I didn't word that very well. What I meant is just the sum total of each of the columns, which represents the survival number of people at each one of those columns or years. Okay, so we have alive after 1 year, would be this column right here, over total patients, which is this first column right here. And the P1 is 1 year survival using 5 years of patient data. Okay, I just added the totals here for convenience, so it will be alive after 1 year, 2065 over 2176. And that equals, let me do it in my head really quick, 0.989888971. We'll just do 4 decimal points. So we have 0.9490, so 94.9% survival rate in first year. Okay, congrats, we've made it about 1/5 of the way through. So next we're going to solve for the probability of living 2 years for those who have already lived 1 year. That's an important distinction. So the formula is essentially the same. We're going to take alive at 2 years over not total patients. So I put a ... So it's total patients at year 2, or you could say alive at year 2, or year 1 rather, after year 1, after 1 year. And there's one more condition. That is, they need to have at least a year, an additional year of survival data. So those enrolled in the last year of the study only have 1 year survival data. So they're not going to get included. However, in our totals, in our total column here, they are included. So we need to subtract them. So it's going to be total patients after 1 year survival with at least one more year of data. And that's not how you're going to typically write it out ever. That's me putting it into my own words conceptually to understand it. And if that doesn't make sense to you, I would suggest you do the same. Write it out in your own words so you to the point you understand it. And I think that's better to do that than to just memorize a numerical alone equation. So what's going to go into our formula here is our year 2 survival, which is 1580 over 2065 minus 377. So here it is right here. I put it on this bottom denominator in parentheses. If you were doing it in a calculator, that might be advantageous, or you could solve for this first and put it in so you don't have any order of operations errors that mess up your calculations. So this is what we have here. This is equal to P2. So this is essentially our equation that we wrote out here. It is 1,580 people or patients are alive after 2 years, 2-year survival, over total patients at year 1 with at least 1 more years of data. So it is 1580 from all the patients enrolled after year 1. So all the patients that have lived at least 1 year, survived 1 year, minus those who don't have more than 1 more year of data, or an additional year of data, who don't have enough data to get included in that calculation. And that comes out to, just going to put an arrow here, 0.9360. I'm going to solve for probability of probability of survival of 3 years among patients that have lived 2 years. And that's going to be essentially the same thing. We're just going to change alive at 3 years. Total patients alive after 2 years. So we're looking at survival among those who have survived 2 years and have at least 1 more years of data. So that would mean that we are excluding patients who enrolled in the study in 2003 or 2002 because they don't have enough data to have 3 years survival recorded. So let's find those values in the chart here. Last one was 1580. We're looking at 3 years now, so it is 1062, if I read that right. Yes, 1062. That will be our numerator, our top number, divided by 1580 minus 500. 500 is the number of patients alive from the 2002 cohort at 2 years, and after that, there's no more data. We don't include the 2003 patients alive after 3 years because that data doesn't exist yet. That's why it is empty in the table. So we have 1062 over 1080, and that is our solution, which equals 0.9833, or 98.33%, which would be interpreted as 98.3% of patients who have survived after 2 years, their probability of surviving 1 more year, 3 years. Patients who have survived 2 years, probability of surviving an additional year. So we should have the hang of it now, and I'm just going to take this 3 years out and put in x, and we will solve these last two very quickly. Say x minus 1. Before 762 over 1062 minus 260. And that equals 0.9501 or 95.01%. 95%. What does that mean? 95% of patients who have survived 3 years have a 95% chance of surviving at least an additional year. And our final 5-year probability will be 224. You can see it's the same figure, both on the top and the bottom. That's because we only have one cohort or 1 year of data from 1999. So we're going to take that and we're going to put it over the total number of patients who have survived 4 years and who have an additional year of data. So that would exclude year 2000. So it will be 297. We can just skip the math, but you could also do the math if you're unsure. You could do 762 minus 297. Sorry, not 297. Big mistake there. 762 minus 465. But again, we don't even need to do that because we just know it's 297. But if you want to do it just to feel confident, or if you don't understand the things and you're just plugging numbers in because you don't understand what's going on, you might still get the right answer. The answer is 224 over 297, which is 0.7542. And we have one more step, and that is to multiply all of these to get the overall 5-year survival using the life table method. So here they are. You can just multiply them on your calculator, either one at a time plus the next one. It doesn't really matter. Forget that part if that sounded confusing. But you can just, and by the way, we're not going to be particular if you use parentheses to put, if it's P parentheses 2 or just P2, it doesn't really matter. We're not picky on that. And that's also a small hint on what one question you might have to do a manual text entry on. Because most of the test is multiple choice, except for, I think, one question. You can guess what that one question will be. And here is our answer, 62.59%. 5-year survivability using the life table method.